Good afternoon. Welcome to today's HydroCAD webinar. Today we're going to be talking to folks at CULTEC Products about modeling CULTEC Stormwater chambers in HydroCAD. And we'll be looking at how you would model these products for a variety of different conditions for stormwater storage and infiltration and other such uses. Our guests today are Gina Carolyn, who is the CULTEC Chief Operating Officer and Marketing Director. And also from CULTEC, we have Fred Dotson, who's the Vice President and Sales Director. I'm going to be your host for today. I'm Peter Smart. I'm the developer of HydroCAD, and I'm also going to be handling the session on modeling CULTEC products in HydroCAD. So for a start, Fred is going to talk a little bit about the modeling of CULTEC, or excuse me, a little bit of background on CULTEC products, just what they are and where they're most useful. After that, Gina will talk about the CULTEC calculator, which is a spreadsheet tool which allows you to do basic sizing and storage calculations for CULTEC products. And then I will pick up with a session on actually modeling the CULTEC products in HydroCAD, doing more detailed storage calculations and even routing stormwater flows through them. And then Gina will wrap up the session with a discussion of the Genie tool, which CULTEC provides, that allows you to generate CAD drawing blocks for CULTEC products in AutoCAD. So that is the rough session for today, and as I say, once again, please do type any questions as you go along, and we'll get to those in gaps between the sessions. So before I hand it over to Fred here, I just wanted to do a quick poll and find out how many folks have used CULTEC products before. It would help us just to get a rough idea of who our audience is so that we can gear this session to the folks that are joining us today. Okay, that looks pretty good. Looks like about 2/3 roughly have used CULTEC products, with about 80% of you who have voted at the moment. So thanks for that. Let me close out that poll. And I'm going to turn this over to Fred, and Fred will tell us a little bit about CULTEC products. So good afternoon, Fred. Welcome to you.
Well, hello. Well, I'm Fred Dotson. I'm with CULTEC. And I just want to start by thanking everyone for such a large turnout today and having an interest in HydroCAD and CULTEC. I'm going to take you through just the basic components of the CULTEC systems and different areas where we can utilize a CULTEC system. Well, about CULTEC. We're one of the founding companies of plastic chambers used for stormwater and wastewater systems throughout the United States, Canada, Mexico, Guam, Puerto Rico, and Europe since 1986. And we're the first chamber to ever be manufactured that's modeled in HydroCAD since 2003. Currently today, there's different technologies used for subsurface stormwater systems and above ground systems, such as metal pipe, concrete pipe, plastic pipe, concrete structures, ponds, and swales. And CULTEC's a great option for both commercial and residential applications. I'm going to go into some detail, taking each one of those and breaking it down. A typical CULTEC subsurface stormwater system, this is what it would be laid out like, typically under a parking lot. And it's a quick little breakdown. I'm going to take each component and go into a little bit more individual depth here. First, we'll start off with our stormwater chambers. Those are actually the storage chambers. To the right are our feed connectors that are utilized for an internal manifold. Then we have our accessories, such as our polyethylene liner, which would be laid underneath the manifold system, and our geotextile filter fabric, which surrounds our system to keep soil from intruding into the stone. And then we also have our water quality structure that's utilized for maintenance of our systems. Basically, the simple operation of how our system works, water would enter in from a collection source such as a catch basin, and it would exit out into our manifold system, which would bring the water into our storage chambers. Now, a common misconception is that when they look at rows of chambers, that they think that the water flows down each individual row like it would a separate pipe. But actually what happens is the water enters into the chambers, it falls into the 6-inch base of stone, and it feeds from the bottom, builds up typically like if you were filling up a pool or a bathtub. CULTEC offers probably the largest variety of sizes than any other chamber system that's on the market today. We actually have 9 different size chambers. We have our contactor series, which is our lower profile chambers, and we also have our larger volume chambers, which are our recharger series. The most popular models that we have in our CULTEC in our different size chambers. We start with the 100 here on the left. It's 12 inches tall. Our 150, which is 18 inches tall. Our 280, 26 inches tall. Our 330, 30.5 inches tall. And our V8, which is 32 inches tall. Now, in comparison to, say, a large diameter pipe, advantage of a chamber system would really be that it can store a larger volume of water in a lower profile. If you look at the structure of the arch, it's wider at the base, so at a lower profile it can handle more stormwater than, say, that pipe there to your right. The water would have to build up to actually the midway point of that pipe to utilize its full storage capacity. And if you take a look at, say, our 30-inch tall chamber, which is our recharger 330, comparing that to a 36-inch diameter pipe, where actually the outside diameter is actually 42 inches, the 30-inch tall chamber holds more storage volume than that pipe, which is 42 inches in outside diameter. So, storing that water at lower profiles is advantageous, especially when you're limited in depth. Now, I talked about the manifold before. When CULTEC first started, we had to rely upon a pipe manifold, taking different diameter pipes, fabricating them with T's and 90-degree fittings. It became very expensive and cumbersome, and actually added an extra need for excavated area on the ends and an extra stone. Next, CULTEC came out with its own design of an external manifold, which was actually a series of chambers running perpendicular to the system of storage chambers and being fed with a feed connector. But today, we're utilizing the internal manifold of CULTEC, and I'm going to try to label these out for you and show you where these are. And basically what those are, they're just mini chambers that you can add in really anywhere throughout the system. Generally, they're used on the beginning and the end sections, but they can actually be brought in anywhere you would want to bring the water into the system. It could be on the sides or the ends or the starting sections. Product features and benefits. Well, CULTEC is the original patent holder of the overlapping rib design. Simply taking a large open end and dropping it over a small rib that's preceding it. But another advantage to our patent is that the fact that underneath each overlapping rib design, there's a support panel, which actually gives superior strength underneath each connection, making our connection the strongest point in the line. And CULTEC relies on HDPE for its resin to produce our chambers, and we chose that because it's chemically resistant to most chemicals found in your stormwater runoff. And as you can see with these containers, each one of those is made out of HDPE as well. Now, for shipping and stockpiling on either a storage facility or on a job site, the chambers are palletized, so we can easily move them around and store them. But now for shipping, we can actually fit on a typical flatbed truck, say a 48-foot flatbed truck, we could fit a little over 14,000 cubic foot of system per truckload. Now, comparing that to, say, a large diameter pipe or even a concrete structure, you're shipping a lot of air. So we broke down a 48-inch pipe by 20-foot length. You can only get 8 lengths of pipe on that same truck and less than 2,000 cubic feet of storage per truckload. And if you break that out, it would take about 7 truckloads of that pipe to get the same volume as 1 truckload of the CULTEC chambers. CULTEC also wants to, assure that the contractor is extremely comfortable with installing our product. So, before we actually even ship the product, we like to try to meet with the contractor on site and do a little meeting with him to make him comfortable and make sure he's got all the proper necessities for and installation instructions for installing our system. And taking you through a typical installation, what you would do is you would excavate a big hole to the depth and length and width that was designed on the drawing. And you would lay down your filter fabric down the sides and the bottom. And then you would then place your base of stone down. Typically it's 6 inches, but that can be increased to get extra storage volume. As before, I talked about that polyethylene liner. A lot of people ask what that is. Well, you would lay that down underneath where your manifold would be, because where the water inlets into the system, we want to keep that stone from scouring if there's a large rush of water coming in. So it's a impervious liner that just lays underneath the manifold to keep the stone from scouring. Next, where you want to put your manifold, each chamber's got a knockout on the side. And you would just take a reciprocating saw, cut that out, and then place your feed connector into that hole that you just cut out. And that's all, as you can see, laid there on top of that liner. And then you just continue to lay out all the adjacent row starter chambers and connect all your feed connectors. And that's basically your manifold. It's taking the manifolds that I showed before with the pipe and the external manifold and just placing it within the system, because now you're minimizing the amount of extra excavation on the ends of the system. And it's doing the same thing. So once you've got all your starter chambers laid out, you basically just take the next chamber, which is a large open end, and you drop it over the preceding closed end of the chamber that was just laid down. And then you would just continue to build your system outward. Connecting, I recommend placing all the chambers, left to right and building outward from there. Then that way what you can do is start bringing your stone above the system. Again, typically it's 6 inches over the top of the system, but extra stone can be added to gain extra volume. Then you would lay down your filter fabric. And in this picture, it's a little difficult to see, but right here is your filter fabric. They're starting to lay down over top of the stone. So now the sides, the bottom, and now the top of the stone is going to be fully enclosed with that filter fabric, again, to keep soil from migrating into that stone. Now, also in this picture, there's these orange dots. What those are, the contractor had sprayed the optional inspection ports with a spray paint to be able to bring a pipe up to grade so that they can later monitor and inspect the system at any time. And then here would be just an overview, a typical cross-section kind of detailing everything I just spoke about throughout that installation. You've got your geotextile down around the bottom and sides and top. You've got your 6-inch base of stone. You got your starter chambers and your manifolds. Then you backfill your stone all the way around the chambers with your typical 6 inches above. Your filter fabric, then your compacted fill above that, and then your pavement. And all that's detailed in our installation instructions. For each model, we break that out so that there's no questioning. It's pretty black and white. CULTEC also offers tiered systems, and that's a nice advantage where you're limited in length and width, but you've got the available depth. So you can maximize a large storage volume within a smaller square foot area. Now, maintenance is a big issue that a lot of engineers bring up. Like, how do you clean out these systems? Well, CULTEC recommends putting something on the front end of the system before the stormwater enters into the system. Here's a quick little animation of the stormwater entering into a manhole with a diversion weir. The diversion weir kind of forces the first flush of rainfall to be diverted through the storm filter. Within that storm filter, there's 3 collapsible frames with filters that the stormwater would flow through with a solid bottom that the sediment would drop out into. And on the back side of that storm filter, the clean stormwater exits into the system. Now when the storm system intensifies, that stormwater will overflow that weir, and at that time the sediment would have dropped out into that weir or been collected in that storm filter, and the cleaner stormwater will bypass that storm filter and enter into the system. And as you can see with the storm filter, before it opens up, there's a turret at the top that you could bring up the grade with a manhole so that that can be accessed and be cleaned out just like a tank with a typical vac pump truck. When we have CAD designs that would detail that, kind of what I just showed with the manhole, the storm filter, and then your chamber system. And we also have an OM guide that would detail everything that I just talked about. Instructions on how to maintain it. Now, because CULTEC has its integrated end wells, it's a perfect solution for residential dry wells. As you can see in this picture here, there's many different applications where you could utilize the chamber, but over in the back corner here, there's using it for a pool backwash. Right here, right in the driveway, the downspouts are tying right into a stormwater system right under the driveway. It can even be utilized for septic systems. So it's a great choice for residential applications as well. It's just kind of overlooked in many cases. Now, as we try to make it as easy as we can for the contractor installing our systems, we want to make it as easy as we can for the design engineer, because, of course, if his job can be as simplistic as we can make it, maybe he'll want to use our product more often. So here's a contact page that you can take down some information to contact us if you've got a design coming up, because we have a staff of technical people that can help out with any of your designs. I'm going to take you through some of the tools and design aids that they can help you with. We can do preliminary calculations, basically entering in your parameters of length, width, and depth that's required in your storage volume, and it will draw out a whole scenario with amount of stone and storage volume and all the essentials that you would need to back up whatever design you're creating. Another nice design aid is the fact that an engineer can email us a site plan and give us the limitations of where we can put the system and a storage volume that we have to create by, and we can actually create a system, drop it right in onto their site plan, and email it back to them. That's kind of what we did here. And for our website, if you go to cultec.com, if you check out the stormwater product section of our website for specific product downloads, such as CAD files and PDFs, and if you go into the download section, there's some more general information located there. And then we also have full detail sheets that you can put into your blueprints. Basically, it's also great for submittals for contractors, because it just kind of separates out everything. You've got your cross sections, you got your 3-view drawings, your end wall detail breakdowns, your starter, middle, and end sections, and how they interlock with one another, and some details on our manifolds, all in one sheet. It's a nice informative sheet there. We also do free competitive comparisons. In the above picture up here, we're just showing a chamber system utilizing a typical pipe manifold system. And as you can see here, with all these different fittings and fabricated tees, they become quite expensive, and they're breaking the system up, which is actually adding extra area of excavated space. If you look below at the CULTEC system, utilizing these internal manifolds, we're able to bring the system together and not space it out so much. We're able to shrink down the system by over 10 feet in length and width. And not to mention, I don't want to forget to mention that with these fittings, pipe fittings, I mean, these can be extremely expensive. They could be, upwards around $100 a piece. for each tee. And you take a look at our internal feed connectors, each one to the end user is approximately $30. So, I mean, depending on the model, but I mean, that quickly adds up, and you can save a tremendous amount of money for, now you're talking about a smaller footprint, less chambers overall, that internal manifold, and the fact that we don't have any extra end caps, which is an extra expense as well. And just to briefly summarize everything that we just discussed, a large variety of chambers, an internal manifold, the maintenance structure, the storm filter, can store large volumes of water in a lower profile, less excavated area, less stone, made of HDPE plastic. They nest easy for shipping and stockpiling, and a simple overlapping rib connection, an interior support panel underneath each connection, ideal for residential drywall applications, and free in-house technical assistance. And I want to thank you all for listening to my spiel here. I'm going to turn things over to Gina Carolyn. She's going to go into a little bit more depth of the technical assistance and design aids that we have to offer.
Hi, everybody. I'm Gina Carolyn, and I've created a lot of the design tools that you may be using if you've been using our products. And the reason why we've created most of them is because I needed them. So out of necessity, I've started to create some of these tools, and the first thing I'm going to talk about is our stormwater design calculator. And we created this to assist in designing our systems. And it's available on our website and also on our design tool CD. And we found that this calculator can be used as a first step to figure out the bed layout prior to routing the system in HydroCAD. So I'm going to tell you how it works. The first step is to input the system parameters. And you have to fill in the workable depth. That means how deep can you install the system. For instance, you might be limited by a high water table or ledge. You also fill in the required storage volume, the desired bed width, and by playing around with this number, you reconfigure the number of rows wide the system will be. We also have stone porosity. It's filled in automatically as 40% as the industry standard. However, you might want to use a different number, and you can change that. Then also we have stone foundation depth, and you can pick 6, 12, or 18 inches from the pull-down list. You also have to choose the type of system you want to specify. Is it going to be a retention system, meaning that there's no outlet and a header on only one side of the system, or is it going to be a detention system, meaning that it's going to be utilizing an outlet and it has a header on both sides of the system? We also place several hyperlinks within the spreadsheet. For example, on the graphic on the top, if you click on that, it will automatically bring you to hold on a second. Automatically bring you to cultec.com, and you can find a lot more information on our website there. Once the parameters are filled into the calculator, it automatically calculates the system. And you always want to try and get the number of chambers required to be equal to or as close to the approximate unit count that you can. This way you don't over-design your system. And you can control this by playing with the desired bed width parameter you filled in at the top of the spreadsheet. The approximate unit count is a quick calculation that doesn't include the storage within the stone borders. So that's just a quick calc, and you want to make sure that you're trying to get your number of chambers below that, because the stone border will give you some extra storage. And the system output section gives you the bed layout, the number of chambers the number of rows wide by the number of chambers long per row, the storage provided, the bed width, the bed length, the bed depth, the stone required, and the storage provided per chamber when installed in stone. And if a chamber can't be used based on your parameters, for example, if it won't fit within your restricted depth parameter, then the output for that model will show as dashes instead of numbers in the chart. And we do have other models available. However, the calculator is for our most popular and cost-effective models. If you click on the model name, it will bring you to a web page specific to that model. And this is an example of a product-specific web page you would get if you clicked on a model name from the chart we just saw on the last slide. And you can see all the available downloads are located on the right-hand side of the page. There are CAD details, submittal packages, brochures, and installation instructions. The calculator will also provide a detailed material list, which we've found very helpful for budgeting and ordering of product. In the cost estimate section, you can fill in the cost of each item to get a budgetary cost and to compare the cost of systems between the different products. The calculator automatically updates the table once you put in the unit costs. And you can call CULTEC for budgetary unit cost to fill in the estimate. Next, you're going to choose the model to specify. You use the pull-down list to choose the model you want to pick. In this case, we're going to choose the Recharger 330XL. The tabs located at the bottom of the Stormwater Design Calculator bring you to the output worksheet specific to each model. In this case, we've chosen the 330XL to specify, so we will click on the corresponding tab so we can view the system summary. The worksheet gives you a summary of the system, which can be used as a report and also included in your system designs. They're also helpful for contractors who need to do takeoffs and submit bids because everything's right there in front of them. And it also creates an incremental storage table, as you'll see here, specific to your the output. And as a final step, you just have to make sure that you save your project spreadsheet with a unique file name so you don't overwrite the original master calculator file. And that's it for me on the calculator at this point. And so I'm going to be switching over to Peter Smart as the presenter. He is the developer and also the founder of HydroCAD, and we're very excited to be working with him.
Great. Thank you, Gina and Fred. That's very interesting information. What I want to do is really pick up from where Gina has left off here with their calculator, which is designed to give you a basic idea of how many chambers and what size field you need in HydroCAD. And let me just switch us back over here. And what I want to do is show you a couple of specific HydroCAD examples. So let me clean this up. Here we go. I have a preset project, and I could just show you what's already been set up here, but let me show you exactly how this is built. So if you create a new project in HydroCAD or start with an existing project, the first thing we need to do is to create a pond, because the pond is any volume that stores water, such as chambers. So we're going to come over to the palette on the left-hand side here, and we're going to drag a pond into the model. And what I want to start with actually is, I think, a 330XL using our chamber wizard. So these two nodes we have up above here, I've already got those configured. I'm going to set up a new one from scratch to mimic that same scenario. So if we double-click that node, because it's a new node, HydroCAD knows that we want to edit it, and we should name that node accordingly. Just call it 330XL system. And we need to select the type of pond we're going to create. In this case, it's a detention pond because it does have a storage volume. So we'll click the detention option. And when we do that, a number of tabs appear at the top of the screen. And the one we're concerned with right at the moment is the storage tab. So if we go to storage tab, we get a table where we can define the different storage definitions that are going to be used within this pond. A pond can have just one storage definition, but it can also have multiple definitions, and we're actually going to use that here for setting up a chamber system. So if we double-click a blank line or click the Edit Storage button, they'll do the same thing, and we'll get to a screen that lets us select the storage type that we want to define. We're going to look at some of the basic options in just a minute, but I want to start with the real quick one, which is the Chamber Wizard. And if we pick the Chamber Wizard and click OK, we come into the Chamber Wizard screen. And the first thing we want to do on this screen is to drop down our list of chambers and come in and expand the CULTEC section down here. And then we're going to come way down this list, and we're going to pick the 330 Recharger 330 XL. And on the screen we get a cross-section showing a single chamber, is what we're looking at. And you'll notice that the screen at the moment is telling us that we have one row and one chamber per row. So that's our initial setup. And in order to create a larger field, what we can do is we can increase the number of chambers per row, so our row gets longer, and we can increase the number of rows. So just that easy, we can specify the number of chambers that we need in this field. Now you'll notice the chambers are tight together in the current illustration. We don't have the stone that we need, either in between them, above, or below. That's all controlled with the parameters over here on the left side of the screen. So we can increase our row spacing, and if we put a little bit of stone in between, you'll see how the chambers spread apart. We can also put stone at the sides of the field, at the ends of the field. So that takes care of our plan view. And then in our elevation, we also need some amount of stone base, which we can increase here, and then stone cover. Now the easy way to do all of that is that we can use this box up top labeled Use Typical Spacing. When we select that box, it will automatically fill in the manufacturer's recommendations for this particular chamber. So if I select that, you can see these boxes have been filled in and grayed out. So we have the recommended amount of stone between above and below the chambers. We also have the stone voids, and this defaults to 40%, as Gina has mentioned. 40% is a best case scenario, so you definitely want to check the stone you're using, perhaps measure it if you need to, in order to determine what the actual voids are. We can also set a side slope or side Z, so if you wanted to allow for the fact that your excavation may not have vertical walls, then we could slope the walls out on the side like that. And then for modeling purposes, we are typically going to specify the invert elevation for this overall system. We don't have to put this in if all we're doing is evaluating the storage, but if we're going to connect this to other elements of a drainage system, then it's important to know what the actual elevation of the system is. So what we've done here is we've just picked a specific chamber we want to use and the number of rows and chambers per row. So if I go to one of Gina's examples that she ran with her design calculator, she was using 120 chambers in that example. So perhaps we do this with 6 rows and 20 chambers per row. So that would be one scenario. And the wizard lays out the chambers with the specified spacing. Then it calculates the size of the overall stone field that is needed to encompass those and gives us an analysis of that system. So it's showing us the total, the width of the chamber, 52 inches wide plus 6-inch spacing. So these chambers are 58 inches on center. And we have 20 chambers in each row. And the chambers are 7 feet long, so we get a total length of 140 feet for the row, plus 12 inches of stone at each end, so we have 142 feet is the overall base length of the stone. Then on the next line, we have 6 rows, which are 52 inches wide, plus the 6-inch spacing, times 5 of those, plus the 12 inches of stone on the sides, so we get a total base width of the system of 30½ feet. And then we get a similar calculation for the height. We have a 6-inch stone base, The chamber is 30½ inches high, and we add 6 inches of stone cover for a total field height of 3.54 feet. Now it's important to notice here that this cover stated in HydroCAD is just the stone. We're just looking at the storage element. So your total fill to grade or to the base of your pavement is in general going to be somewhat greater than that amount. We're just looking at the storage issue here and not necessarily the structural issue of how much cover you need. And then on the next line, we have a total of 120 chambers in the system. Storage in each chamber 52.2 cubic feet, and this gives us the total amount of storage in the chambers themselves. Next, the software calculates the overall square footage of our field, our excavation, and the total volume of that. It subtracts the volume that the chambers are displacing. This gives us the amount of stone that is needed. There's 40% voids in that stone, so now we get the amount of storage available in the stone. And then if we take the storage in the stone and we add the storage in the chamber, we get the final storage provided by the entire system. So that's essentially what the wizard is doing. It's making that layout process very quick. And we could start the wizard, as I've just done, by using initial numbers from the CULTEC calculator, but you can also just adjust the parameters here until you get the storage that you need for the overall system. So it's a very quick process, trial and error process of adjusting these parameters. You can also adjust the amount of stone. You're not restricted to those default values, so those can be changed as well. The calculator, or the wizard here, has also got a couple of other neat little features. You can also use this for doing rough cost estimates. So you can put in a chamber cost, you could put in an excavation cost, you could put in your stone cost, and select show costs, and you'll get an approximate cost for that system down the bottom based on those parameters. You can even include additional materials. So you could put your filter fabric in here or any other items that you want to include in that. And this is very handy when you want to compare the costs for different chamber alternatives and see how they compare. So this is how you set up the wizard. Now if we click, just turn the costs off for the moment. If we click OK on this, HydroCAD now creates two separate storage definitions. The first of these, which is called Field A, is the outer excavation, which is backfilled with stone. And then inside that, it is placed the CULTEC chambers. And this column where it says inside number 1 is what indicates that the chambers are inside that stone field. So this has all been set up automatically using the wizard. Let me click OK again on the overall pond definition. And so we've now described this pond. If we double-click this pond, because we've already entered data for it, HydroCAD knows that we want to update calculations for the pond. Now, we don't have any inflow hydrograph through this pond at the moment. It's just an empty volume sitting there. So our hydrograph is blank. But if we look at the tabs up top, we could start with the wizard tab, for example. And this shows us the report we were just looking at. Here's our system layout. And if we go to the stage discharge tab, actually stage storage tab is what I want, excuse me, this is showing us not just the total storage in the entire field, but it's showing us the storage in the field at any given elevation. So on the left axis, we have the elevation for the system over here. So starting at our invert of 100, and as we fill that system with water, the storage increases. And what you can see here, if you look closely, is that this first 6 inches of our stone base, we have a linear increase in storage because it's just the 40% voids in the stone. Once we come up 6 inches, we get to the base of the chambers, and now the storage starts to increase more rapidly. We have that point of inflection. And when the chambers have filled completely, we get to the top of the chambers, and then we have 6 inches of stone cover or whatever it may be at the top. So that's what you're looking at with this stage storage relationship. And you can look at this in a graphical or a tabular view. There are a lot of different options available for you here. Switching to a 2D view gives you a slightly clearer image of where that transition point is and the chamber storage. So that's what would happen if you just want to calculate storage. You can throw it in as easy as that. Now, in most cases, you're using HydroCAD because you want to do a more complete analysis of how the water is flowing through that system. And so here I have a subcatchment, which is generating a runoff hydrograph, which is then routed into a pond with the chambers. And this is exactly the same pond that I've just set up for you. If we double-click this pond, HydroCAD will update all the calculations to that point in the system. This hydrograph is showing us a green inflow curve. And so this is the runoff that's coming from our subcatchment up here, and that's running into the pond. Now, this particular pond has no outlet devices. We just have storage. And so the black line here indicates the elevation in the pond. So this is our underground chamber system filling with water. And so you can see there's very little runoff until about 11, 12 hours into the storm, and then the chamber system starts to fill, and after about 24 hours, 25 hours, the runoff is stopped, and the chamber has reached its final elevation. So we're able to do that kind of scenario here of just a detention system. We could take that system and we could add overflow devices, we could add exfiltration for allowing for a water loss into the surrounding soil. So for example, if I click Edit and go to the Outlets tab, then we have no outlets at the moment, but let me create one. Let me double click, and perhaps we're going to put an overflow in. So I'll select culvert if this is going to be a pipe, and let's put this in at 103 feet, let's say, up near the top of the system. And I'm just going to put a couple of parameters in here really quickly so we can do this. So let's put a 6-inch overflow into this system, and we need an entrance energy loss coefficient. Click, click. And so now we have just a very small amount of overflow that's actually occurring because our water was just getting up to the 103. If we were to lower that culvert slightly, let's bring it down to 102.5, for example, now we start to get a little more flow, and you can see in the gray curve we went up to that peak and then the water level started dropping. And we can use the same procedure to put in an exfiltration outlet or infiltration so we can allow for water loss into the surrounding soil. So you can model all of those different scenarios in HydroCAD. What I've showed you so far was a setup using the Chamber Wizard for the 330XL. I also want to show you just briefly an example using the V8 HD. The V8 chamber system is a little bit different in that it has a start and end chamber on each row, which are slightly shorter in length than the main chambers in the system. And so that's a scenario where you might want to do a manual setup for your chambers. So let me show you that to you really quickly. Let's drag another new pond into the system and double click that to edit. Select the tension pond. And this is where Gina's calculator could be particularly handy, because what we could do here, we can come in and now when we define our storage, rather than using the Chamber Wizard, we're going to define each of the storage elements manually. So we're going to pick the prismatoid option to define our outer excavation that we're going to fill with stone. And here, let's put that in at 100 feet for an invert elevation. And now we could take the numbers off the calculator. So very roughly 24 feet for a width and 184 for a length in the example I have, and a height of 4 feet. Again, these are rough numbers just to make that easy. And then we want to set the voids. So that's our 40%. So this is a box of rocks with 40% voids inside that stone. We click OK, and there's our prismatoid definition. And actually what I should have done is I should have labeled that stone field or something of that nature so that we and our reviewers have a better idea of what we're actually doing here. Then on the next line, we'll go down to a blank line, double click that, and now we're going to put in a prefab chamber. So we're going to pick prefab chamber, we're going to go to the drop down list, and we're going to pick the CULTEC V8 HD down here. And if those chambers are going to be 6 inches off the bottom of the field, then we need to set the invert at 100.5 feet for the chamber. It knows what the effective length of the chamber is, so we need to set the number of chambers in this particular example. Gina is telling us that we've got 92 chambers. And this stays at 100% voids because this is the open space inside the chambers. You don't want to set this to the 40% stone. That would be simulating a case where you had filled the chambers themselves with stone. So you leave that at 100%. But the magic here is that we need to specify that these chambers are being embedded inside volume number 1, which is our excavation. So our second line here, our second storage definition, are the CULTEC V8s embedded inside the stone field. Now I mentioned that the V8 has slightly different length start and end units, so we need to put in one more storage definition here, which is again going to be a prefab chamber. And we're going to come down the list here, and we're going to pick the CULTEC V8 start and end unit right here. And we're going to set our invert elevation again for 100.5. And we need to specify that we have 8 of these chambers. So in this scenario, we've got 4 rows, and we have a start and end unit on the end of each row, so a total of 8. And we need to embed these again in our stone field. So now we've set up our main or intermediate chambers, the start and end chambers, all of those embedded within the stone. If we click OK and then double-click this node and come to our storage tab, we now have our overall system. So the V8 system is a little bit more complex to set up because you do have to set up the start and end chambers. Our next HydroCAD release 9.2 next year will actually handle this automatically in the wizard. If you do use the wizard for the V8, and you can do that, you just need to be aware that it is going to be calculating slightly greater length for the row of chambers because of this difference in the length of the start and end units. But you can still do that. And you could actually take a wizard model initially, and you could come back and modify that and fine-tune it later on in order to put in the start and end units. So that's the basic process that you can use for setting up any of these systems. And the HydroCAD chamber library lets you pick any of those CULTEC chambers or other products, even pipe storage, which is handy for doing a comparison. As Gina has pointed out, or Fred has pointed out, it takes a lot more height to put in a pipe system. So you could rough in a pipe system of comparable storage, and this would tell you how it would compare with a CULTEC scenario. So that's a rough look at what you can do with HydroCAD. I was curious to find out how many folks who are joining us today have used HydroCAD before. This would be helpful to us. We can fine-tune any questions. Just looking at the questions that have come in, yeah, I don't see anything else yet pertaining to HydroCAD. So I'm seeing about 2/3 of you, again, have used HydroCAD before. That's with 77% of us having voted. So that's good to know. We do have a previous webinar that has been recorded and is available on the website on chamber modeling in HydroCAD. So that's a full hour specifically devoted to chamber modeling. So I would urge you to go back and have a look at that if that's of interest. Another question we were curious about is whether folks would be interested in an additional, more detailed session covering specifically CULTEC products and HydroCAD. So if you can give us your feedback on that, then that would be of use to us in future planning. We do have a session coming up in 3 weeks, I believe, on HydroCAD tips and tricks, which is a general review of a lot of different capabilities. So I'd urge you to go and look at our webinar listing. I'm sure you'll find new capabilities there that would be of help to you. I see we've got something over 80% would be interested in an additional session on this topic. So I think you can look forward to seeing that scheduled in the future. Thank you. Okay, so next I'm going to turn this over to Gina briefly, and Gina's going to talk about the next step in your workflow, which is taking this chamber system once you've designed it and modeled it with HydroCAD, and capabilities that CULTEC provides to help you create your CAD drawings for your submittals. So Gina, let me turn it over to you.
Great. All right, so the next thing I'm going to talk about is another design tool that kind of just came about. I've been wanting to do it for several years, and we finally brought it to life. So it's pretty exciting to me. And what it is our Storm Genie automated drawing program. And as far as I know, we're the only manufacturer who has anything like this that draws directly in CAD. So it's pretty exciting for us. So I'm going to tell you a little about what it is. The CULTEC Storm Genie, it's an AutoCAD plugin that allows you to generate a CULTEC Stormwater system in AutoCAD based on the information you entered into our Stormwater Design Calculator, which we talked about earlier. And it creates the corresponding system based on the model you selected from the pull-down list in the calculator program. And it's really quick. First, you fill out the Stormwater Design Calculator and save the spreadsheet like we did and talked about earlier. And then you go into AutoCAD and click Storm Genie. And this will show up in your toolbar once you have installed the program. And it automatically then creates the bed. And this is a free program, so it's available on our website here. And you don't have to jot down any notes because I'm sure you'll get a copy of the webinar. And I'm just going to blast through some of the examples here. So I'm just going to go through the individual steps. First, you fill in the system parameters into the calculator, like we said earlier in the presentation. And then you're going to choose the model you want to put into your design and save the spreadsheet with a unique file name. And make sure you save it somewhere you can find it easily later. I've done that and can't find my spreadsheet. So make sure it's easily accessible. And once you're in AutoCAD, you first have to open up the CULTEC DWT template that came with the Storm Genie program. The Storm Genie can't generate the CAD drawing without first opening this template, so you want to make sure that you open that first. And after you've opened the CULTEC template, you'll run through the Storm Genie program and browse back to the spreadsheet that you saved. And the Storm Genie will automatically draw the bed in CAD. And once the drawing is generated, you can pick and plot it to include it onto your site plans and detail sheets and move it onto your own title blocks. The drawings are accurate. There's no more trying to figure out the center-to-center spacing or the row lengths or trying to figure out the hatching. It's all drawn for you. And it includes the hatching to tell you the different model types, such as the starter, middles, and end sections. And it has a material list that's easy for takeoffs and ordering of the product, which we find is very helpful to the installers. That way, we don't have to try and figure it out. It's all right there in front of them. And that's basically it. It takes a long time based on, the slides that we just did step by step. But once you open AutoCAD and the calculator spreadsheet, it's pretty straightforward. So from now, I'm just going to do real quickly, just show you exactly how quickly it draws the bed for you. So here we're in AutoCAD, and you'll see that up here, the Storm Genie is now showing you in your toolbar because you installed the program. So like I said earlier, the very first thing you have to do is open the CULTEC DWT template. Mine just happens to be in my pull-down list because I've been using it quite a bit. And then I'm just going to zoom in here. Then you're going to go up to the CULTEC Storm Genie on your toolbar. Click Run CULTEC Storm Genie. And it brings up this browsing section. So we're going to browse back to our spreadsheet. This is what we're browsing back to here is the Stormwater Design Calculator that we saved. And that was specific to our project. And voila! Are you impressed? Here's our bed. And you can then manipulate it. You're able to grab this and put it directly onto your site plan. All this is now included. There's the materials list is all updated. This is all project specific based on the calculator. We're calling out all the different hatchings. We're saying that the storage, what was required and what it was provided. And you also have all the correct dimensions. So all these different pieces, these are all accurate lengths. Here are your feed connectors for your internal manifold. This green hatching is showing the polyethylene liner that Fred talked about earlier that goes under where your manifold is located. You've got your center-to-center spacing is all called out. So it's a pretty handy little thing. We found that it's really good for when you want to do just a quick drawing, like if you're using just for preliminary conceptual things for clients. But it's also good for if you wanted to be able to manipulate the bed and know that you're starting at a accurate unit pieces. The sizes of the units are all accurate. So I'm going to get out of here. That was just showing you the Storm Genie, but now we also have available our CULTEC bed design aids. And this is in case you needed to create an irregular size bed or you choose not to use our Storm Genie program for whatever reason. And so you can use these to manually draw the beds. And it will come up like this in CAD. And it has instructions of how to use it here. You can fill in your materials list. Here's all the correct piece sizes that you can either use this sample bed and manipulate the sample bed, or you can take these bed blocks and create your own system using that, or add or take away pieces as needed. So we're calling out the materials list, the hatching, and all the correct unit sizing. And that's basically it. So if you have any questions in regards to these things that I just spoke about, you can type them in now and we can discuss them. And I think we're ready for our wrap-up, Peter.
Okay, excellent. Thank you so much, Gina. And just a couple of comments before we lose you here. There is a free CULTEC edition of HydroCAD, and you can get more information about that at cultec.com. And that's a complete HydroCAD system that you can use for modeling CULTEC chambers. Of course, you can also get larger capacity systems and the ability to model other chamber products using the software that we have directly from HydroCAD. Here's the general contact information, and you can certainly get this on the websites, either at cultec.com or at hydrocad.net. We're not hydrocad.com, but that's actually an Israeli fluid power hydraulics site. Similar name, very different kind of feel. So at hydrocad.net, you'll get more information about HydroCAD. We did have a couple of questions I'm not sure we'll have time to get to right now, but we will answer those by email. I promise we'll get you answers. I think at the moment, if there's nothing more from Gina or Fred, I'm going to thank them both very much for joining us today. It looks like we probably will do a follow-up session to this at some point in the future. And I thank you for joining us, and I hope that we will see you at a future webinar. Thank you very much, and have a great day.